Imagine a humanoid robot that can physically outrun Usain Bolt, clear a 2-meter vertical jump, and it is entirely powered by a digital brain that learned how to move just by watching a 3-second video.
It's honestly hard to wrap your head around.
It really is. Welcome to episode 606 of AI Brief. I am Amin, and I am joined by my co-host, Leah.
Hi, everyone.
So our mission for today's deep dive is to explore the blistering, almost unbelievable speed of artificial intelligence advancement happening right now. Like, at this very second, we are tracking a major shift in how breakthroughs are delivered. We'll be unpacking a mysterious new coding model that is suddenly challenging the biggest players out there.
Out of nowhere, really.
Totally out of nowhere. And we're also analyzing that record-breaking humanoid robot ahead of a massive initial public offering, plus a fresh batch of AI productivity tools.
You know, what makes today's updates so remarkable is how they highlight a massive industry shift. The most disruptive breakthroughs are no longer coming from familiar, expected sources with well-choreographed press releases. They are arriving entirely out of nowhere. And more importantly, they are moving directly out of the digital realm and aggressively into the physical world.
It's a completely new era. So let's dive into the software landscape first, because we just witnessed one of the most aggressive, stealthy model drops of the entire year. It's a system called Ox Alpha, released via News Research.
Oh, this is fascinating.
Yeah, I mean, think of this situation like a mystery supercar showing up at a prestigious racetrack. It rolls onto the tarmac without any license plates.
And carrying no recognizable manufacturer badges.
Exactly. But it suddenly lines up against the established champions and absolutely shatters the track records. The specifications on this model are staggering. We are looking at a multimodal reasoning system equipped with a 1 million token context window.
Which is huge.
Huge. And that is paired with roughly 131,000 token maximal outputs. Plus, there's this wild headline-grabbing claim attached to it, which is the capacity for 1 quadrillion tokens per day.
Well, to really grasp the gravity of those specifications, we have to look closely at what 131,000 token maximum output actually means for software engineering.
I feel like people get context and output confused all the time.
They do. Usually, models have large context windows, meaning they can read a massive amount of information, like reading an entire library.
Right.
But their output is often bottlenecked. They can only write a short essay in response. Ox Alpha can essentially write a novel.
Which changes everything.
Exactly. During a public demonstration, the model utilized that massive output capacity to generate a complete procedural 3.js 3D scene in a single response.
Just to put that in perspective for a second, generating a 3.js scene isn't just writing a simple block of text.
Not at all.
The AI is doing complex spatial mathematics. It's defining camera angles, lighting, and object geometries using code all simultaneously.
And it produced over 64,000 output tokens continuously to build that scene, without requiring any external assets or secondary prompting. It didn't pause, it didn't lose the plot, and it didn't hallucinate halfway through the rendering process.
That is wild.
It is. That demonstrates an extraordinary level of sustained reasoning. I mean, a model that can hold its train of thought for 64,000 tokens of raw code is a fundamental leap.
So currently, the model is available for free for a limited time through the News Portal, and access has propagated rapidly through OpenRouter, OpenCode, Klein, Venice, AML API, and various agent tooling ecosystems. But I do want to issue a critical warning here for anyone rushing to try it out.
Very important point.
Yeah, the providers have stated a, quote, zero data retention policy, but that should be treated strictly as a testing commitment. Please do not upload sensitive corporate data or proprietary code bases to an anonymous, unverified server, no matter how good the output is.
Seriously, don't do it.
Just don't do it. But looking past the security protocol for a moment, the early coding test demands serious attention. Ox Alpha hit an 80% pass rate on an early 10-task coding subset. To put that into perspective, that performance easily beats Fable, which scored 65%.
Oh, wow.
And it beat JLM 5.3 at 62% and GPT 5.6 of 52%.
I mean, while that 80% pass rate is undoubtedly impressive, we must remember that a 10-task sample is small and directional.
True.
It is not a definitive, comprehensive leaderboard result. However, what is truly fascinating here is the mystery surrounding its creator.
Right, who actually built this thing.
Exactly. Model watchers have confirmed it is not tied to Thinking Labs. The prevailing suspicion points towards Epho, potentially a GLM 5.3 vision variant, because its tokenizer similarities and behavioral signals match up so precisely.
Okay.
But Xiaomi's Mimo line has also been heavily discussed as a possibility, though neither theory is confirmed.
That brings me to that astronomical figure I mentioned earlier, the 1 quadrillion token daily capacity. Wait, a quadrillion?
Quadrillion.
That number sounds physically impossible given current global compute limits.
Yeah.
I mean, are they talking about purely fresh generation, or is this a clever accounting trick using cash tokens? Because serving a quadrillion newly generated tokens a day would require a server farm the size of a small country.
That is the exact debate happening among independent researchers right now. The mechanics of serving that many tokens almost certainly require massive amounts of cached input tokens.
Which makes sense.
Right, because cached tokens demand significantly less computational overhead than fresh generation. But if we connect this to the bigger picture, the underlying mechanics almost take a backseat to the broader impact.
How so?
Well, the genius of this stealth distribution strategy is undeniable. It turns global evaluation, mass demand generation, and deep competitive intelligence into one unified, entirely risk-free launch strategy.
That anonymity creates such a fascinating market dynamic. Ox Alpha is effectively attacking the market where frontier labs are currently the most vulnerable. It delivers highly useful coding performance, distributes it cheaply, maintains total anonymity, and does so at massive scale.
Exactly.
The true disruption is that a model can generate this level of serious industry attention before its parent lab, its training methodology, or its underlying economics are even known.
It allows a parent company to observe how a massive 1 million token context window handles long-horizon software engineering tasks and sustained agent work in production workloads.
Without any of the PR risks.
Exactly. All without risking their core brand reputation if the experimental model breaks down on edge cases. The rapid adoption across platforms like Venice proves that developers are eager for high-output reasoning models, regardless of whose logo is on the API.
Well, we just spent all this time marveling at how fast artificial intelligence brains are evolving in the digital world. But what happens when you drop those hyper-advanced brains into physical bodies?
Things get real very fast.
Right. That brings us to what just happened in Shanghai, which completely flips the script on robotics. I'll let you take the lead on breaking down this hardware news.
Sure. The financial shockwaves originating from Shanghai represent a pivotal moment for the physical application of artificial intelligence. We're observing the blockbuster initial public offering of Unitree.
The numbers on this are crazy.
Oh, they're staggering. On its Shanghai debut, Unitree's shares soared over 460% above the IPO price, eventually closing at 845 yuan.
Wow.
This exceptional market response values the company at approximately $50 billion. That far outpaces the average first-day pop for Chinese listings this year.
$50 billion. That is massive.
And what is crucial to understand about this valuation is that Unitree is one of the few humanoid robot makers actually turning a profit, which dramatically changes the economic narrative around robotics.
It's not just hype anymore.
Exactly. The founder, Wang Xingxing, whose personal stake is now worth more than $11 billion, made a profound statement regarding this financial milestone. He claims that the robotics industry has officially reached its, quote, ChatGPT moment.
That is quite the claim.
It is, but parallel to this financial validation, we are seeing major leaps in the software that powers these physical machines. Generalist AI recently unveiled its GEN 1.5 model, which introduces the concept of one-shot robot learning.
One-shot learning.
Yes, this system allows a robot to pick up a completely new physical skill from a single 3 to 12-second video demonstration.
See, that ChatGPT moment claim from Unitree's founder is perfectly illustrated by the physical hardware they unveiled just days before that massive IPO. They pulled the curtains back on a new humanoid robot appropriately named Superman.
Such a fitting name.
It really is. The raw specifications are genuinely jaw-dropping. This robot reportedly hits a running speed of 12.7 meters per second.
Which is incredibly fast.
It's insane. That effectively edges out Usain Bolt's world record-setting speed of 12.4 meters per second.
Unbelievable.
On top of outrunning the world's fastest man, the robot can also clear a 2-meter vertical jump, which beats the human standing high jump record.
That kind of physical power is unprecedented.
And combining that raw, record-breaking physical speed with the GEN 1.5 software model's learning statistics creates massive implications. The stats show a 59% first-try success rate after watching that brief video demonstration, and that success rate jumps to 83% after just a few minutes of extra practice.
It's mind-blowing.
So instead of engineers manually coding every single joint movement, this model just watches a video, maps the physical space, and tries it.
The mechanism behind it is incredible. When a model like GN 1.5 processes a 3-second video, it is essentially translating two-dimensional pixel data into complex three-dimensional joint motor commands in near real time.
That is so wild to think about.
The underlying learning mechanism behaves remarkably similarly to how a human toddler observes a parent's movement and attempts to mimic it. To understand why this is revolutionary, think about older reinforcement learning models. Those models required millions of digital iterations to learn a simple walk cycle.
Right, the old simulation environments where they just fell over endlessly.
Exactly. It was like a golfer taking a million swings in a pitch-black room until they accidentally hit the ball perfectly. Now, the system simply watches a professional golfer take a swing once, understands the physics involved, and replicates the motion.
That's a great analogy.
And the fact that the robot achieves an 83% success rate after just a few minutes of practice indicates a highly efficient visual feedback loop.
So does this unique combination of unprecedented physical speed and rapid, toddler-like digital learning mean we are truly seeing the birth of physical general intelligence, or PGI? Even if these companies openly admit the specific skills are still developmental, it feels like a massive threshold has been crossed.
It really does. The convergence of hardware capable of 12.7 meters per second and software capable of one-shot learning is exactly what drives the physical general intelligence conversation. Right. Industry watchers calling this an early sign of PGI are looking at that detectability. A robot that can physically outperform a human in raw metrics, like a 2-meter vertical jump, is impressive engineering.
Very impressive.
But a robot that can dynamically learn how to apply that physical power to completely new unprogrammed tasks based on a 12-second visual prompt represents a fundamental leap in machine cognition.
It's not just a pre-programmed routine anymore.
Exactly. It bridges the gap between pre-programmed factory automation and true general-purpose physical utility in the real world.
Well, moving from the future of autonomous robotics and stealth frontier models, let's focus on what listeners can actually use on their computers today. The ecosystem of productivity tools is expanding so rapidly, but there is a clear theme emerging, which is the death of context switching.
Yes, finally.
Instead of opening a new tab and visiting an AI chatbot, the intelligence is coming directly to your workspace. There are 6 trending tools that perfectly illustrate this shift. First up, we have Framer AI agents. This tool is designed to instantly generate and publish professional websites,
Which saves so much time.
The practical use case here is moving from a raw design concept to a live coded site in a fraction of the time without ever leaving the design interface.
That's huge.
Then there's Supernova. If you are struggling with scattered company documents, Supernova acts as a data funnel. You use it to connect all your disparate data directly into Claude and Codex, providing those models with your exact organizational context so they actually know what your company does.
That data consolidation piece is so critical because an AI is only as useful as the context it has access to.
Exactly.
Funneling that data directly into the model eliminates the need to constantly copy and paste internal documents into a prompt window.
It's such a pain to do that.
You go.
And the next 3 tools take that seamless integration straight to software developers. We have Felix, developed by Vercel. This is a tiny open-source coding agent that developers can deploy for quick, localized development tasks without spinning up massive, heavy environments.
Very efficient.
Fourth is Antigravity IDE Extensions. This allows you to put anti-gravity agents directly inside your existing code editor. The immediate benefit is total immersion. You no longer have to constantly tab between your coding workspace and a separate chat window to debug a problem.
I love that.
Fifth on the list is Epho. This tool allows you to run Claude Code, Codex, or OpenCode directly in the cloud alongside your repository. It seamlessly integrates advanced models into your existing version control environment.
That is incredibly powerful for teams.
And finally, for enterprise users, there is OneCLI. This platform provides a secure, centralized solution to give every employee on your team a sandboxed professional assistant agent. It ensures strict enterprise-grade security while distributing these capabilities across an entire workforce.
Providing an overarching view of these 6 tools reveals a very clear practical angle. We are observing the fundamental breaking down of the walls that once separated complex models from daily routine workflows.
The walls are just coming down everywhere.
They are. These tools are systematically turning every standard code editor, browser, and cloud repository into a centralized command center. It is no longer about treating artificial intelligence as a separate destination.
Right, like going to a specific website to ask a question.
Exactly. It is about the intelligence living natively inside the environment where the actual work is being executed.
That native integration is exactly what makes this current wave of technology feel so instantly impactful on daily productivity. As we wrap up this deep dive, we have traced an incredible trajectory today.
We really have.
We started with Ox Alpha, an anonymous software model capable of generating entire 3D worlds in a single massive prompt, effectively challenging the most established frontier coding models on the market without even revealing its creator.
A true mystery.
We then moved into the physical realm, witnessing a $50 billion valuation for a profitable robotics company whose newest machine can literally outrun human Olympians.
Still can't get over that.
I know, it's crazy. All while new learning models allow these robots to master physical tasks from a simple 3-second video. And finally, we looked at how those powerful digital brains are quietly integrating into our code editors and design spaces. It leaves us with a final provocative thought to consider.
Oh, what's that?
If anonymous software can spin up complex digital architectures in seconds, and humanoid robots can learn physical interactions almost instantly while possessing superhuman speed and agility, how long is it before these stealth, highly capable software models are directly piloting the humanoid robots walking around our homes and cities?
Oh, wow. That is a lot to think about.
It really is. Thank you for joining us on this exploration. Please be sure to follow and share the podcast to stay updated on these rapid advancements. See you in the next episode.
Thank you for listening, and farewell until next time.